In this video, our goal is to delve into a key component of spatial analysis, calculating travel times. Mastering these calculations is essential for effectively utilizing the IGC-CSM model, as many of the urban policy interventions we will examine involve positive or negative changes in travel times across the different parts of the city. Travel time calculations enable us to determine the duration required to move between locations. These commuting times are a crucial factor influencing the spatial distribution of economic activity. Before we dive into the calculation, let's review some key concepts. First, distance is the physical length between 2 points. In travel time calculations, we measure the distance that vehicles or pedestrians need to travel along their routes rather than just the geometric distance. Second, the speed is the rate at which people can travel. This may differ based on the type of road or their mode of transportation. And third, the travel times are the total duration required to cover the distance at a specified speed. This will be the main data input of the model. Transport interventions can impact travel times by either altering the distance or the speed of travel. For instance, constructing new roads can reduce the distance between destinations, while improving the quality of roads can change the speeds. These changes ultimately lead to modifications in travel times. When identifying use cases for the model that involve changes in travel times, consider how different interventions impact travel time. You need to determine whether these changes are influenced by adjustments in distance or in speed. For instance, a collapse of the railway system may increase the distance users must travel between locations, while dedicated lanes for bus rapid transit systems can enhance the travel speed. When evaluating transport interventions, your objective will be to calculate two travel time matrices, one reflecting the times under the baseline condition and another one showing the times in the counterfactual scenario after policy interventions are implemented. First, let's discuss the essential components that are required for the calculations of travel times. You will need a set of centroids. These indicate the geometric center of each location within the city and should be stored as a point shapefile. You will also need a road network that outlines the characteristics of all the roads in the city, like average speed, length, and location. These should be stored as a shapefile of lines. Additionally, if you plan to evaluate a counterfactual scenario that alters travel times in the city, you will need data to identify which routes will be impacted and how they will be impacted. This information can be provided in the form of a table detailing the IDs of the affected roads and their associated changes in speed, or as a shapefile showing the geographic locations and the extent of the changes in speed. The following steps will guide you in producing travel time matrices. This tutorial is a simplified version and does not account for additional details related to transport infrastructure, such as switching between different modes of transport, like bus to metro or car to walking, wait times for transportation, road elevation, peak hours, traffic distribution, or car ownership. Now, let's walk through steps to perform this operation in GIS. Here, we have a map of Cape Town showing the different areas in the city. We also have the centroid showing the geometric center of each of these locations. Our goal will be to construct a matrix of travel times that shows the amount of time that it takes to go between every pair of centroids. We also have a network of roads that go across all the city. Although it looks a bit busy, you can zoom into any part of the city and see how the roads are constructed. The first step to calculate travel times will be to connect the centroids to the network of roads. To do that, we will use a tool from the Processing Toolbox in the Vector Geometry section that is called Snap Geometries to Layer. What this will do is that it will locate the nearest road to the centroids. The input layer will be the centroids and the reference layer will be the roads. We will select a tolerance parameter of 10 degrees. When you run this, you obtain a new layer showing centroids mapped to the nearest road. If you open the attributes table from the roads layer, you will see that each road has some assigned attributes. As you can see, they all have a class assigned, a name, and an average speed in kilometers. They also have the total length of the road and a variable showing the minutes that it takes to travel that road. This variable can be obtained by dividing the length in kilometers by the speed in kilometers. With these attributes, you will be able to compute a travel time matrix across all the pairs of centroids in the city by using a plugin called QNIT3. You can download QNIT3 by accessing the plugin menu and selecting Manage and Install Plugins, and then looking for QNIT3 on the plugins. Once you have installed QNIT3, go to the Processing tab and select the toolbox to access the plugin. We will be using the distant matrix function OD matrix from Layers Outline. Here, you will input the network layer, which are the roads that we have already defined. And for the front point layer, we will use the centroids that we have connected to the network. And for the 2-point layer, I will use the same layer of centroids that we have mapped to the network. And the optimization criteria, which will determine which is the best route to go across 2 points, I will select the fastest path. We will also need to go to the advanced parameters to set the speed of the roads. We will also increase the topology tolerance parameter to its maximum level in order to avoid gaps in the network of roads. Now we press Run. The result of this step is a new layer called Output OD Matrix showing lines connecting all the centroids in the city. If you want to see the time that it takes to travel across 2 points, you can access the attributes table from this layer. The variable total cost contains the time in seconds that it takes to go from one centroid to another centroid for all the centroids in the city. This data is now ready to be exported as a CSV file and then structured as a matrix using R. If you would like to brush up on how to export this data, please refer to the video integrating GIS with other data sources.